Hello everyone, this is Priya Kaushal from the Department of Economics. I hope you all are fine, and today we are going to discuss about the types of matrices. So let's start today's lecture. So the first type is rectangular matrix. A rectangular matrix is a matrix in which the number of rows are not equal to the number of columns. So this is a very simple kind of simple type of a matrix. Very easy definition or a meaning of it. When the number of rows are not equal to number of columns, then it will be called a rectangular matrix. It also gives a shape of a rectangle. You can see here that in this example we are having 2 rows and 3 columns, means these are not same. Rows are not equal to columns. So this is a rectangular matrix. Next is square matrix. As the definition of a square, all sides are equal. So here when the number of rows are equal to number of columns, then it would be called a square matrix. So it also gives us a shape of a square. You can see when you observe this matrix, you can see here that it is just like a square. As the number of rows are equal to number of columns, then it is a square matrix. So okay, it can be extended up to any numbers. So here I have given you 2 examples of 2 by 2 order and 3 by 3 order. So here we have 3 rows 3 columns, and in this example we have 2 rows 2 columns. So both these matrices are square matrix. Next is diagonal matrix. What is a diagonal matrix? There are 2 conditions for a matrix to be a diagonal matrix. The first condition is it should be a square matrix. First condition. The number of rows should be equal to number of columns. And the second condition is all elements are zeros except on the main diagonal. Means the main diagonal elements are non-zero and all the other elements are zero. That is called a diagonal matrix. And what is a diagonal? The diagonal are, these are the diagonal of a matrix, like A, I, J, where I is equal to J. Here I have given you a definition of diagonal elements. So you can see from here that a diagonal elements are elements A, I, J, M by N for I is equal to J. Means if I is equal to 1, then J is also equal to 1. Then its position would become A11. If I is 2, J is also equal to 2, yani it is A22 element. If I is 3, then J is also equal to 3, because here condition is I is equal to J. So A33. So these are the diagonal elements. So in the diagonal matrix, these diagonal elements are non-zero and all the other non-diagonal elements, they are 0. So this is a diagonal matrix. So here I have also given an example, a matrix B. Here you can see that diagonal elements are 1, 7 and 10. So all the other elements are 0. So this is an example of diagonal matrix. So I hope it is clear about the diagonal elements. So diagonal elements can be A11, A22, A33 and so on. Because we have the condition here that I is equal to J. Next is scalar matrix. Now there are again 2 conditions for a matrix to be a scalar matrix. The first is it should be a square matrix. The second is all the diagonal elements should be equal. So you know very well about the diagonal elements. So now all these diagonal elements should be equal, not equal to 1, other than 1. Okay? So these are 3, 3, 3, 4, 4. These are the scalar matrix. Next is identity matrix. Again, it should be a square matrix. All the diagonal elements are equal to 1. So that is the reason when I told you about these elements to be other than 1. Because when these elements become or equals to 1, then it becomes an identity matrix. So यहाँ पे देखो आपके पास यहाँ पे है 2:2 ऑर्डर की एक मैट्रिक्स A, यहाँ पे है 3:3 ऑर्डर की मैट्रिक्स B. So you can see here that the diagonal elements are equal to 1. Here again diagonal elements are equal to 1. So this is an example of identity matrix. And again a third matrix C, which is of order 1:1. Here is we have only one element in it and it is equal to 1. All these are examples of identity matrix. So when we have C type of matrix, then we denote it by a letter I. And when we have A and B type of matrix, then we denote it by a n. Okay, understand that? Next is null matrix or zero matrix. It is clear from the name that when all the elements are equal to 0, then it is a null matrix. Again, next is row matrix. When there is only one row in it and any number of columns, then it is called a row matrix. Here is example A. So it is just like a single row matrix. Here you have only one row and any number of 3 columns are here. Any number of columns can be there. Next is column matrix. So in this type of matrix we have only one column in it. Okay, so any number of rows can be there. It can be row 4, 5, 6, 7. So this is called a column matrix. Next is upper triangular matrix. A matrix is called an upper triangular matrix when first is it is a square matrix. Second, all the elements below the principal diagonals are 0. So you can see here that this is the principal diagonal here, 2, 5 and 8, and all the elements below all the elements below this principal diagonals are 0, 0, 0 and 0 are there. So if you see here that, if you observe here that they are making an upper triangle here. The non-zero elements are making an upper triangle. So this is why it is called an upper triangular matrix. Next is a lower triangular matrix. You can see here that the elements above the main diagonal elements are 0 and all the other elements are non-zero, and in this type of matrix it is making a lower triangle with the non-zero elements. When we see on the non-zero elements, they are making a lower triangular or a lower triangle. That is the reason why it is called a lower triangular matrix. Next is a submatrix. What is a submatrix? When we form another matrix from a mother matrix, then it is called a submatrix. So this is the mother matrix. By deleting some rows and columns from this matrix, we can make another matrix. This is called the submatrix of matrix A. So you can see here that this is 4, 5, 5 and 2. We are using only these elements, 4, 5, 5 and 2. So you can see here that the third column is deleted here and the second row has been deleted from there. So by deleting the third column and second row, the left elements make a sub matrix, whatever name you can give to it. Okay, so this is the lecture for today. Meet you in the next video. Till then, take care and goodbye. Thank you.